Good morning, good afternoon, good evening. Welcome to our Informix Tech Talk. I am Lester Knutsen, the producer of the Tech Talks, and I'm very excited to bring you this one because I'm actually doing the Tech Talk. I'm going to give you an introduction to Informix performance tuning. This is the first lesson in our 4-day course that Art and I do. And we're going to go over how you do a scientific examination and my top 10 performance tuning tips. So this webcast is pre-recorded. The slides will be available at the IIEG website and the replay. But please keep your lines on mute. Background noise tends to distract everybody. And if you have questions, please use the chat button. I'm going to be online answering questions while you ask them during the recording. So just a bit about me. I'm Lester Knutsen. I'm semi-retired, but I still love Informix and still love working with it. And so I'm going to dive right in. And this is what I'm going to talk about today. These are my top 10 Informix performance tuning tips. But before I do that, let's talk about the goals. The goal of performance tuning is to get the best balance of resource: memory, CPU, disk, and network. There are 4 things you have to look at for your server and for your database. And I like to follow what I call the scientific method of tuning. And this is the scientific process. You ask a question and define the problem. This is the problem you're trying to solve. Then you observe and measure is the key word here. Then you build a test plan, and then you do an experiment to see if it works. If it works, you put it into production. If it doesn't work, you go back and repeat this process. And it's very important when you do this to communicate your results. Here's an example. When we teach the class, we have a benchmark worksheet we do. And we always start with a baseline. That's this number right here. It says it took 17 minutes to run this benchmark. And we measure the CPU used and the memory used and the disk I/O used. And then we start making changes. And you can see this first change jumped from 17 minutes to 8 minutes. On down to change number 15, got it from 17 minutes to 21 seconds. And record each change. It's kind of interesting. A number of times in a class, a student will say, "Oh, I got it really fast." And I'll say, "What did you do?" And they're like, "I don't know." It's very important to record each change as you do it. Now, where do you get this data from? Onstat-P. Page reads and buffer reads, which is what I track right here. Disk I/O is page reads. Buffer reads is that. Are right there on Onstat-P. Your CPU time is right there and very easy to identify, and the amount of memory used is right there. Now, a word on variance and why it's important to run a particular test over and over again. I had 8 machines, exact same hardware, running the same benchmark script for 24 hours. There is a 5 to 6% difference in times over that 24-hour period and 8 machines. You'll get some variance as particularly when you get down to the minutes and 1 or 2 minutes of time. Now, on VM machines, that variance is quite a bit higher. Doing the same 8 machines on VM machines, I found a 21 to 26% variance. In AWS, Amazon Cloud, I saw a variance of 14 to 58%, depending on the configuration. So you'll get variance. That's normal in part of this, and that's why you need to measure to see what the variance is. And so oftentimes when I'm timing something, if it's 5% worse or better, I may not worry about it unless I'm on VMs. And then if it's 20% better or worse, you may not worry about it. The other key thing is to make one change at a time, and after you make the change, measure. And I want to point out clock time, because a lot of times improving the clock time, that means the Informix server is taking less time. And let me go back to this slide. This is the clock time right here. I add these two, user CPU and system CPU. If you can reduce that, you can free up more resources for other things to run. I was working with a client once where they had an application they ported from Microsoft SQL Server to run on Informix. The first test, they had a benchmark. I thought this is great. And the first test they ran with almost a default configuration, it beat their benchmark. In fact, the problem with their benchmark is they could only do 40,000 transactions an hour. And they beat that. And so what we said, well, let's focus on CPU time. And can we reduce the amount of CPU time the server uses during that hour? And then you can put your system on cheaper hardware. It won't need that much CPU time. So this is very important to also focus on CPU time. Disk I/O, I'll talk about that all throughout this. Network traffic are all things you need to look at. The key though is make one change at a time. So let's dive in. Okay, the first thing, and this is sort of in order of what I've found makes the biggest change, is having the correct indexes. A huge difference. This will reduce unnecessary sequential scans and unnecessary disk reads. Now there is something you have to watch where you have too many indexes, and that can be a problem, but not having an index is a bigger problem. And let me give you an example. When I started doing benchmarking years ago, I had a SQL query, a batch billing job that was very poorly written on purpose. And running that in a default configuration, I've also run it with multiple tuning configurations, but one index was missing. And this is what happens. I reran this again not too long ago just to see if it was still true. With new hardware, a default configuration, the one missing index, it took 10 days and 45 minutes to run. That's a long time. With a little bit of tuning, I could get it down to 9 hours. So from 10 days to 9 hours, that's good. But it still has the missing index. Going back to my default configuration and adding the index, it's 7 minutes. And this is why. With the default configuration and the missing index, it has to do a lot of page reads, a lot of I/O. And I'm going to talk about this later, but the buffer turnover ratio was 4,779 times in an hour. That means it was trashing buffers in memory very rapidly. With a little bit of tuning, I brought that down to 1 time an hour, but still a lot of page reads. It didn't help the performance. By adding the one index, it reduced the number of page reads and got it down to 7 minutes. So finding sequential scans is my first tip. And here's a script I use to go out and find sequential scans. And let's just see if I can run it here. I'm going to fire up DB Access, go into query language. I'm going to pick the SysMaster database, and I'm going to run the script. It's in my SysMaster scripts. If you have downloaded them in the past, you have this script out there. And I am going to put out a new version of the scripts in the next months. But here, this is a good example. In my Benchmark 2 database, the bills table, It had 144 scans. This is what's important, is how many pages were scanned. That means it's just trashing buffers reading those pages. The second highest one is in that same database, the customer table. It had more scans, but it's a smaller table, so the total pages scanned was not as high. And what I think is important here is the total pages scanned, not the number of scans. If you have a table with one page, hopefully that page will be scanned every time, because it's faster to scan one page than to scan an index and a page. That's going to be 2 reads. So reading the page directly once is faster. So for a small table, sequential scans are good. That's why I look at the pages scanned, and that is taking the page size times the number of scans will give you the pages. So that's key. Second thing is, how do you monitor your indexes to see how well they're used? And here's just an example. I've got an index. I take reads and writes, and I've got a ratio of 1 to 3. That's not very good. What you want to see is something like this, where you have a ratio of an index being read 677 times to 1 write. And let's just see if I can get that script up here. Here's an example. This is a great index. I've got an index. It's been used, 1.9 million times. It's been read to writes. That gives you an idea of how good that index is. Now I come down here, I have an index that's only been read 2 times to a write, and that's not so good. This index is actually kind of interesting. In my benchmark, this is a missing index. So I wouldn't drop that index, because everything will go really slow without that index. But this gives you an idea of how good indexes are. You still have to know your data and know the indexes to tell which ones are used. Like, I would not drop this one, because this takes the job down from 10 days to minutes. Okay, the second thing is to shrink the table schema so more rows fit on a page. Informix reads and writes data in pages, and you want more rows to fit on a page. Taking 1 or 2 bytes off of a column can sometimes get it to fit and to allow more rows to fit on a page. I'm going to talk about table waste. One key thing, though, I want to point out that I've done a lot is, if I have a big table, like a customer table, and I've got a core set of columns that are used all the time, and then everything else is sort of extra, not really used, create 2 tables. One is a master table, and the other is the extra table. And put all your columns that are seldom used in that extra table. And the master table should have everything you need to do your daily operations, like billing. It will need the address. It will need flags that you may use for billing. The extra table will have comments and things that aren't so important to that. The idea is to get the master table small. Here's an example in my benchmark scripts. So here's something that took 2 minutes down to 5 seconds. And the difference is the row size from 1,266 bytes to 116 bytes. I took everything that was not needed out of that bills table and shrunk it down to just what was needed. And it went from, this was a well-tuned system, so it went from 2 minutes to 5 seconds. So shrinking your table schemas can be a huge improvement to performance. Now, a couple of tools for monitoring schema size. Art has a great script called waste.sh you can use. You can also use the Informix Compression estimator. Compressing, and in 14, compression is now included with the product. One of the best reasons to upgrade to 14 will also reduce the size and how many rows can fit on a page. So this is a great use for big tables. And here's a calculation I have for rows per page. You basically want to take the page size minus 28 bytes divided by the row size plus 4 bytes, and that will tell you how many rows fit on a page. And then you want to take the rows per page and multiply that by the row size to tell you how much of a page is filled with data. The rest of the page is waste. And you then want to take your data page size and subtract that from the page size, and that will tell you how much is waste on that page. And then you want to take a estimated waste for the whole table. You want to take this waste and multiply it by the number of pages used, and that will give you an idea of how much has been used. Let me see if I have an example here. So here's an example. Now, let me dive down to this example right here. So here's a row in the Benchmark 2 database called the bills, and the row is smaller than the page size. It uses 1,270 bytes per page, per row. It wastes 750 bytes per page. And when you multiply that by how many pages, the number of pages that this table uses, that is what? Let me get the zeros right. That's like 453 million KB. That's a lot of wasted space. So that's the second tip. The third tip is buffer turnover. And this is a key. And basically, you want to look at how much memory is available on the machine and to use as much memory as possible for Informix. Now, you don't want to make it too big because this will slow down the machine by causing swapping. Now, let's go through sort of the basics. When Informix starts up, it creates a shared memory segment for buffers. And every time you read a page, it goes into the buffer so that if somebody else wants that data, it's already there. It doesn't have to get read from disk again. When all these are full, the LRU queues, least recently used queues, kick in, and they start to page the oldest, least recently used data out. Now, when you have updates, this gets even more interesting, because now it can't just throw that page away. It has to write it out to disk. And there's something called the LRU queues that manage writing data out to disk in the background. And I like to call them their background writes. They are not intensive. They sort of do it when things are free. So they may not be fast enough, but I'm going to come to that. But based on the LRU min and max data, they will write things out to disk. Now, if all the buffers are dirty, Informix has to stop and do a foreground write. This is really bad. You don't want to see this. Now, when a buffer is written to disk, it's marked as free, and it can be discarded, and everything goes on. This is buffer turnover ratio, because what happens if you discard a buffer and then you need it again? it has to come back into memory. So this is a cycle of going back and forth. Now a checkpoint comes along and every dirty buffer gets written out to disk. And at the end of a checkpoint, you're clean and this whole cycle starts all over again. So buffer pool. The best practice is the more buffers, the better. You want to put all your active data into memory. I've worked with a number of clients, and with memory getting cheaper, you can add more memory to a machine fairly easily. I've worked with clients that have put their whole database in memory. Or if your active portion is like 512 megs, you can put that in memory easily. My colleague Art Cagle has a great rule, and I'll show you a script that uses to calculate that. He says your buffer shouldn't turn over more than 8 times per hour. I once went to a client site that was complaining about performance and measured it, and their buffers were turning over 300 times an hour. And what we did is we worked out a schedule. Again, you make one change at a time, and we did it gradually over about 4 months of increasing their buffers. And every time we increased their buffers, their performance got better, their buffer turnover ratio went down. So here's a script, and I've been running benchmarks on my machine. So this is that script. My buffer turnover ratio now is 36 times per hour. I could add more buffers. I have 1,500,000 buffers on this system right now, and it's still turning over 36 times per hour. Now, the fourth thing is shared memory virtual size. This is the workspace of Informix. And this will grow, whereas buffers don't grow. You have to shut down the server to increase buffers. Shared memory work size will automatically grow. And the best practice is to have one big segment for it, not a bunch of little segments. Because with little segments, it's going to be fragmented. And if a program needs virtual memory, then it has to go say, okay, which segment has free memory that I can use? And it makes it harder to find it. Here's an example of the problem. If you do an onstat-g and you see more than one virtual segment, here I've got 3 extra virtual segments. That means my initial virtual segment is too small, and I need to make this bigger. And what I would do in this example is take the 24 megs that this server wants and add it to this initial shared memory virtual size, which is in the onConfig. These are all in your onConfig. Just as an example, if I vi opt Informix etc $onConfig, here's my shared memory virtual size, and I document when I make a change how much I've changed it to. So I've made this 200 megs. You need to watch your system and monitor it. Onstat-g seg is your friend here to tell you if you need to make it bigger. A couple of other things about memory I want to point out. One is resident. This controls whether memory can get swapped out. Off as a default, and let me go here to my onConfig and let's look for resident. It's right there. The default is off. I've changed it to 1, and 1 means that the resident segment will stay in memory. It's locked in memory. It can't go out. I could also change it to another number, like 3 or 5, and the first 3 or 5 segments would get locked in memory and never get swapped out. Do not make it -1. I've seen this happen where you make it -1, say I want to lock everything in memory, and then virtual segments get added and you actually lock up your machine. I think a good number is to look at your virtual segments, and if you made it, in this case I would make it 1, 2, 3, 4, 5. It will get the first 5 segments locked in memory. That way, if any other virtual segments do get added, they won't cause a huge lockup in memory. The other key parameter is shared memory add. Now, one of the biggest reasons that virtual segments add is because the lock table grows. The lock table, think of it this way, is the most used structure in Informix memory. And the lock table has a list of every row that is locked, who locked it, and every time you go to read a row, you have to check the lock table to see if you can. And every time you want to update a row, you have to insert a record into the lock table to see if you can. Now, there is a parameter in the onConfig call locks. Let's take a look at that real quick. And here's that parameter. That determines the number of locks when Informix starts. Now, if it needs more locks, Informix will dynamically add to the lock table in the virtual segment, and it will add them as needed. But now you're going to have this lock table spread out all over the place, and this is really interesting. If you go back to my benchmark worksheet, you'll see that I changed the locks. Let me just dive back here. I increased the locks, and it went from 8 minutes to 5 minutes. This is always a very good indication that you're going to get a performance improvement. Now, the way you look at your locks is when you're online, if you do an onstat-k, it will read the lock table. And right here at the bottom, it will tell you how many lock overflows you've had. So let me go back to where I was. Here's an example where I've had 2 lock overflows. And what I would do is make my lock 80,000. Make the parameter in the onConfig 80,000 to handle the 2 lock overflows. Because this is telling you that you really need 80,000 in the lock table. I believe this was a server set up with a default of 20,000. So locks are, one of the top things to do to improve your performance. If you don't have enough locks, it's really important. If it says 0 overflows, you're good. That's what you want to see. Next thing is Temp Space, and Temp Space is really important because most of your disk writes will be to Temp Space. Let's take a look at my server here. If I do an onstat-D, look at my temp DB space. It's got the second most reads and writes, and the reason it doesn't have the most is I've got this big database table that I'm loading right now, and that's why there are more page writes. Once that's loaded, this is going to become much smaller, and my locks are about 4 times the reads. Onstat-D will tell you. Now, it's very important to have DB space temp set to something. And let me just, as an example, if you do an onstat-c, it will tell you what your DB space temp is set to. Now, I only have it set to 1. If I had it set to 3, like my example here, Informix would automatically load balance between the 3, and I would get much better overall performance. And if the 3 were on separate disk or separate logical volumes, even better performance. Here's another example, a database server I/O. You'll have a little bit to the root DB space, a lot of writes to the physical log, a lot of reads to the logical log. Your temp DB space is going to have both reads and writes. And your data space will have mostly reads unless you're doing loads like I am right now. So what causes this I/O? The number one thing is sorts. And you want to work on improving sorts to reduce your use of temp DB space. Now, first of all, get 3 temp DB spaces. And then work on improving sorts. And a couple of things, indexes help a lot. Using less columns, shrinking your sort columns means that you reduce the number of a number of KB that a sort has to do, and it will improve your sorts. There's also a parameter that I think is very powerful called DS non-PDQ memory. This is how much memory to reserve for sorts. And the default in version 14 is 256. In older versions it was even smaller than that. Look at how much sort space is being used. Let me show you a script I have in the SysMaster database, and sort ratios. There it is. I just wrote this, so it's freshly done. This tells me my server's been up 523 hours. I've done 63,000 sorts. I have done 58,000 in memory because I have the DS sort memory variable set. I've still done 4,900 to disk, and this is how much space it takes to do it to disk. All those parameters are in the SysMaster database, and they will be in my new SysMaster scripts that are coming out. But having DB space temp defined is key. Also, if you see a lot of I/O to the root DB space, that probably means there's some non-logged, and DB space temp by default is not logged. There's some sorts that are being done in a transaction. That is very bad programming practice. To do a begin work and then do a sort. And then, it's like, why are you logging that sort? But when that happens, it has to write it to the root DB space because the temp DB space is not logged. If you do a onstat-d, lowercase d, you can see here this T flag for my temp DB space says that is not logged. What you can sometimes do is to create a value and put it in temp DB space for a regular log DB space and create a logged temp DB space. That's a really good practice for this. Next, balance your disk I/O. And this is a long, complicated, and I'm actually throwing in 3 tips here, but I'm putting them together as one. More disk or better. I cringe every time somebody says, hey, now with Informix 14 I can create one big chunk for everything. More disk are always better because you want to spread the I/O out across as many devices as possible. It may not be disk on a SAN, but it could be logical volumes. It could be directories. You want more I/O spread out among multiple things. The other thing you want to do is look at RAID 10, and Art Cagle, my colleague, has great strides on why RAID 10 is so much better than RAID 5. And the last thing I want to mention here is you want to test direct I/O. So RAID 10. The advantage to RAID 10 is it can read multiple stripes at the same time, and they are mirrored. So if one disk goes down, everything else continues. You won't even notice it. With RAID 5, if one disk goes down, that disk needs to be rebuilt. That rebuild will slow down your server. Now, you want to move your physical and logical logs to separate disk out of the root DB space. If you have KAIO and raw disk, you want to use them. You don't. You want to test direct I/O. And sometimes direct I/O works really well. Sometimes it doesn't. And you have to test it in each instance. I had a colleague that was replicating from a server to another server in the cloud. They're supposedly the same. Direct I/O worked on their local server. On the server in the cloud, it did not work. It actually slowed down performance. I was doing a migration to the cloud for a client a couple of years ago, and they had direct I/O on because everybody thought it was the best thing. I ended up taking direct I/O off, and a migration that we thought was going to take over 24 hours finished in about 12 hours. So direct I/O is not always the best thing, but sometimes it is. And you want to test it. The other thing you want to look at is the number of AIO VPs that you have. Too many AIO VPs. Remember, these are processes that write to a disk. And if you have too many AIO VPs, they can become a bottleneck. I once was performance tuning at a client site, and they had 256 AIO VPs trying to write to the same 5 disk. So 256 things were all trying to write to the same 5 disk. That did not work. And I'm a big advocate of turn off auto AIO VPs and manually configure the number. And you have to test what the best number is. If you have KAIO on or direct IO on, you probably only need 2 or 3 or 4. If you don't have KAIO on or direct IO on, you probably don't want more than 2 per active chunk. And that's sort of my benchmark. Never have more than 2 per active chunk, because you don't want 2 things trying to write. They'll be competing with each other. Instead of one writing smoothly, you'll have 2 on-inits competing with each other. And 2's okay, 3 or 4 or 5 is really bad. The other thing I just want to point out, I am bouncing slides, is I did some testing a long time ago with spinning disk. And spinning disk, actually, I found you could not get more than 8 processes writing to a disk at the same time. At 8, performance started dropping after 8. So that's just something to think about. Now, the other thing in this optimizing the I/O is look at your LRU writes. This is the key to reducing checkpoints. And let me just give you an example. I'm going to do an onstat-GCKP because I've been running a benchmark quite a bit, and I've had a number of checkpoints, caused by various things. And in these checkpoints, like this checkpoint right here, I'm writing out 815,000 buffers, 2K buffers. That's about 1.6 megs. Copying a 1.6 meg file is going to take a couple of seconds. And plus, a checkpoint is very I/O heavy, and it will impact your users more than anything else. In our class, when we do benchmark tuning, particularly in the multi-user testing, you'll reach a point where you can't do everything, because every time a checkpoint happens, which happens every 5 minutes, everything just slows until that checkpoint is finished. The best way to reduce the performance of checkpoints is to change your LRU max and LRU min dirty. And what I like to do is, the default is 50 and 60, lower it. Let me go back here and just look at the on config. At the very end of the on config file. So I've got the default of 50 and 60. I have also auto LRUs turned on. Now, auto LRUs means Informix is going to lower these automatically, but it's not fast enough. That's what I've found. When you have a spike in work, Informix auto LRUs don't respond fast enough. You're much better, I think, keeping a low number here. And you can go down all the way down to 1 and 2. Start cleaning when 1% of the buffers are dirty. Stop cleaning when 2% of the buffers are dirty. So for turnkey systems or embedded systems without a DBA, auto LRU tuning is great. For a high performance system, you want to turn off auto LRU tuning and manage checkpoints. Now, number 8 on my thing is to use your CPUs. And a couple of things I want to define real quick here. A socket is the actual physical chip. Every machine nowadays has multiple cores on a socket, and those cores are real CPUs. And you need to know how many cores you have on a socket. Now, to make these chips run faster in benchmarks, most of them have hyperthreads or SMTP cores. And these are cores that allow one core to run multiple cores. Now, they don't really run at the same time. What they do is a hyperthread core wakes up when the primary core is blocked, and it will run. So it gives the appearance of having more cores, but it doesn't really. Particularly if you have something like an Informix server, which is very efficient at just keeping a core busy. And I once did a benchmark with a client where they had a machine with 96 hyperthreads. We ran the benchmark, and we said, okay, let's turn off hyperthreading. We ran with 80 CPU VPs. And we said, okay, let's turn off hyperthreading. So they only had 48 cores. They had no hyperthreads. It ran faster. So this is, again, something you need to measure and test. But look at turning off hyperthreading. Or if you're on AIX, look at SMTP threads. AIX, IBM actually recommends you reduce the number of SMTP threads on AIX, and they have documentation on that. Look at the AIX documentation for databases. Now, other programs will take advantage of hyperthreads. Java programs, if you have a lot of times your application servers, they'll use hyperthreads. But Informix is one big process, on-init process, and it just runs, and it likes to grab the CPU and run a lot. The other thing is your chip speed is really important, and that will tell you how you can run. So here's a couple of examples. So I have 2 sockets with 5 cores each. I made this up, and they're virtual. So it looks like you could have 20 things running, but in reality, only one of these cores can run at a time. So you got to think about how many cores will run on a machine. What I like to do is most machines are fast enough that if they're you can run 1 on a nit per 100 megahertz or 1 gigahertz. So if you have a 3 megahertz core, you could probably run 3 on a nits. You also want to look at how busy your CPUs are, and SAR is a good example. Let me just quit and go to SAR. Running the SAR CPU will tell you how busy you are, and you want to see your system have some idle. And my rationale for that is you want to save it for spikes. So I'm running a benchmark, but I could throw more work at this system, and I wouldn't have to worry because there's some idle time there for workload spikes. I worked with a college once, and at midnight on the day registration opened, that was their benchmark, because then they had 40,000 students trying to get online to get classes, and that was a huge spike. And so their system was fairly idle until that happened. And so you want to save 60% of your CPU for spikes like that. If you don't, then what will happen is your system will grind to a halt when you get the spike. Now again, test, test, test. And you can do onstat -g sch. That will tell you what your on-inits are. Some of them are started automatically. These 5 are automatically started when you start Informix. There's nothing you can do about them. If you have auditing turned on, you'll see an on-init called ADT. And this, by the way, is the class here. Let me go to my server here and do it onstat -g sch. And you can see the class here tells me what I'm doing. You can have user-defined on-inits like Java or your own, but the 2 that you control are the CPU and the AIO. And I talked about AIO on-inits in the last section. As you can see here, I'm running 1, 2, 3, 4, 5, 6, 7, 8, 9 AIO on-inits, and I've got a fairly good set of well, I've got 5, so I could run up to 10, I think, safely on this system, because I have 5 chunks, and you could run 2 per chunk for the AIO ones. Let's talk about the CPU ones, because these do the work. And you set them with the CPU VP class in your onConfig. The key is you say VP class CPU number equal, and then no age tells the operating system not to age it. Because what happens is, if you don't have no age set, the operating system is going to lower the priority of a process that's been running for a long time. This is why you used to have to reboot systems, once a week, once a day, because over time the operating system would say, you're running a long time, I'm going to slow you down and give you a less priority. If you have the word here, no age, that tells the operating system, don't do that. And so here are a couple of examples. This one says I want 4, I want 8. Affinity, I don't use affinity much, but this says turn on affinity and keep these pinned in memory. This option says turn on affinity for the first 4. I typically go with just, depending on how many CPUs I have, like when I had 96 CPUs, we made it 80. Couple of other things. In the onconfig file, there's a value called multiprocessor. Make sure it's set to 1 because that almost all machines are multiprocessor. I think that has changed in 14. You also want to change single CPU VP to 0 because that allows you to run more on inits. If you don't do that, you cannot do this. Another little tidbit, if you have on inits, is to set up a private memory cache for each CPU on init. And you give it the size here. And so if you're running 4 on init CPU VPs, like in this example here, I'm running 4, I would give that much as a private cache to those 4. And that will speed things up because when that on init needs memory, it goes to its private cache first. Now it's not shared, so there's no locking there. If it doesn't have a private cache, it has to go out to the shared memory and it has to deal with locking for that memory. That's called latches. And this will cause latches to happen. So set up a private cache. Dynamic, I don't think is that helpful. I prefer to give it a size. Don't make it too big. 4096 is, I would do it someplace between 1024 and 4096, depending on your system. It will take this memory away from your virtual memory segments and sort of reserve it for that on init. Number 9 on my list is row level locking, and this is a very simple one. Informix defaults to page level locking. For an OLTP system, that means the first person who reads a record from that page and locks it will lock the whole page. And so what you want to do is find pages, and here's the script to do it, that have a lock level of page and change them to row level locking. This is sort of a default easy to fix system, particularly for multi-user systems. If you're a data warehouse, you don't need to do this. If you only have one job that runs a day to do loads, you don't have to do this. But if you have a multi-user, 1,000 user, 10,000 user system, you need to make sure you're using row level locking. The last thing is update statistics. And I can't say this enough. This is super important. I think it's next to backups one of the most important things a database DBA can do. And I have a couple of scripts here. AUS is automatic update stats. And that is run in 12 and 14. Sysmaster, choose AUS last run. And it's run automatically, usually on Saturday and Sunday. And this will tell you when it was last run. And it's interesting, it's missing my benchmark 3 database, which I loaded yesterday. So AUS has not run since I loaded that benchmark 3 database. It's not here. You do have to know this data. It's telling me when, for these tables, the automatic update stats was run. It was run on the 3rd. That was this morning at about 1 a.m. It's really important that this runs because this gives the stats so the server knows, and this is the key thing, how many rows are in each table. Without this, the server doesn't know how many rows are in each table. It will think everything has no rows, and the fastest way to read a table is a sequential scan. So this can be a reason why you're getting sequential scans, not because you're missing an index, but because the update stats has not been run. Here's another example of this from a while back. This is one of my other favorite scripts, is doing this by database, and I create a bit more information. Let's see, update stats info. Again, this is in my SysMaster scripts if you go download them from our website. So I'm going to run this, and it says, okay, in my benchmark 1 database, the benchmark table has never had update stats run. The state table had them run last on February 12th, and high was run, and the zip table, again, February 9th, it was last run. So these are pretty out of date in this table. Let's change this. Now this one you do by database because it uses the system tables in the database. So I'm going to change this to the benchmark 2 database and run it. Again, my bills table had low done, but it's never had anything else done. And I'm going to change this lastly to the database I just loaded, and it will probably tell me that it's never had update stats. It's locked because I'm still doing the load, so I can't do it. Anyway, those are my top 10 things for Informix tuning. Documentation is really important, and something I want to point out that I really like that I just discovered. It's in 14, is the onconfig diff command. This allows you to compare your onconfig to another onconfig or to the defaults. And I use this all the time to compare to the onconfig std. And let me just give you a quick example of that. And so I'm comparing my current onconfig to the standard. And it says, okay, here's some parameters in the standard that I don't have. I did a bad upgrade. I should have copied the standard over. Here are some parameters in 2 that are not in the standard. Temp space is in 2. The server name, that's normal. Here are some differences. This is a great way to document changes to your onconfig and what's going on with your server. Now, on our website, we have a bunch of additional information. When I'm teaching the class, I usually say, we'll talk about this on Tuesday, or we'll talk about this on Wednesday. I couldn't do that today, so I'm going to say a lot of stuff that we've talked about. There's more information on our website in the videos and information that's out there. And I want to point out a couple of things. I have a couple of training classes coming up in May. Art Cagle and I will be teaching the Advanced Informix Performance Tuning class May 23rd. That's basically the class that this talk was based on. This is actually the first lecture in that class. We spend 4 days benchmarking and going through so that you can see what changes affect what performance. It's a great class, a lot of fun to teach it. I'll also have the regular DBA class May 9th to 12th. This is for new DBAs and folks moving to 14. It's a really good choice. Something I'm experimenting with, and this is experimental and coming in April, is I'm working on a new online training platform. And this is a self-paced online class, Informix 4GL for developers. It's got lectures that are videos. You do the labs on your own server, so you need a server with 4GL. There are online discussion groups to talk. Now, you may ask a question, and if no one else is online, you may not get an answer for a day or two. But this is something I've developed. I've been teaching 4GL classes for years, and I thought I would show you guys. And just to show you that it is real, let me see if I can get this over here. This is the website I'm working on, and what it looks like. Now, this is the preview is going to be free. It's going to be the first 8 chapters of the 18 lessons, so you're not getting the whole class. But I want to try this out. It's a lot of work converting it to this format, and I want to make sure it's worth it before I do it completely. If you've had questions, I've hoped you've asked them in the chat. And I want to say thank you. If you have questions, please feel free to email me, lester@advanceddatatools.com. Also, as the producer of the Informix Tech Talks by the IUG, I want to say thank you. I want to show you guys something. I got to not be full screen to show you this. This is our YouTube channel. We have a huge number of subscribers, a lot of good Tech Talks out there. And coming up in April, all the presentations from the Informix user conference last year are going to be on our Tech Talk channel. So there'll be a lot more there. And we've got an exciting one in the works for May. So I'm really pleased with that. And with that, I'm going to say goodbye. Thank you for watching or attending. And feel free to send me any questions that you might have. Bye all.